Okay, now we are going to look at the third question. This is October, November 1921, question number 6. If you haven't read the question, pause the video and read it. Defining electric potential difference. Now, it is defined always between 2 points. So basically, it is the energy energy transferred by each unit charge as it passes through the 2 points, as it passes from one point to the other. So we can again look at it. The potential difference between any 2 points in a circuit is a measure of the electrical energy transferred, or the work done, by each coulomb of charge as it moves from one point to the other. As an equation, energy transferred over charge. It is not the same thing as defining 1 volt. When you are defining 1 volt, you have to mention that energy 2 points, such that the energy transferred from electrical to other forms is 1 joule per coulomb. Okay, so they are two different things, defining 1 volt and defining potential difference, or aka voltage. They are not the same thing. Then so if you look at the mark scheme here, so it simply says energy work done over charge, or energy transferred over charge. But you also mentioned that the potential difference between 2 points is the energy transferred per unit charge when it travels from one point to the other. So you mentioned about the 2 points as well. Then this part is very similar to the earlier question we did, where the very first question, B part. So you are given an IV characteristic of a semiconductor diode, and you are asked to describe it qualitatively, the variation. So basically, now if you look at the graph, less than this value here, that is 0.25 volts, the resistance is infinite and the current is 0. And after that, you can see that the gradient is increasing, so resistance is decreasing rapidly. Okay, so those are the 2 points expected there. Then again, the C part is also very similar, because both of these papers belong to the same series, so some of the parts are very similar. So they're asking you to calculate in C part, the first question, use figure 6.1 to determine the resistance of the diode. So again, just like that 1B question, so if to find the resistance, you need to find the voltage and current. So the current in the circuit is 15 milliampere, so you have to find the corresponding voltage. So if you find the corresponding voltage to 15 milliampere, it will come here, that it would be midway between 0.5 and 1, 0.75. So if you substitute that, yes, so 0.75 divided by 15 milliamps, you get 50 ohms. So in that question, they gave the voltage and you found the corresponding current value. Here they are giving the current value, you are finding the corresponding voltage and proceeding to calculate the resistance. Then calculate the resistance of X. Now this circuit is given. Now we will study about DC circuits separately, but since this is a very basic circuits, you can do it now itself from your IGCSE knowledge. So we want to calculate the resistance of X. If you want to calculate the resistance of X, you know the same current 15 milliampere is flowing through it, so no issue, you can you have the current value, but you need to have the voltage drop across X. If you want to find the voltage drop across X, you have the total EMF, that is 2 volts. So if you somehow manage to find the voltage drop across Y and voltage drop across the diode, you can find the you can subtract them from 2 and you can find the voltage drop across X. Well, we just found the voltage drop across diode when we were doing the question early, this immediate earlier question. So for 15 amps we just found that the voltage drop is 0.75. so we know the voltage drop across the diode. Now you have 15 milliampere and 60 ohms, so you can use V is equal to IR and calculate the voltage drop across Y. Then you can subtract them from 2 and you can find the voltage drop across X. Then you have the voltage drop across X and the current, you can find the resistance. So that's easy breezy. So voltage drop across Y, 15 milliamps times that 60 ohms of the resistance, so 0.9. Then diode is 0.75, so the voltage across X is 2 minus 0.9, the one we calculated here, plus the minus the diode gives you 0.35. so resistance of X is 0.35 divided by the current, 23 ohms. Okay, or you can use V is equal to IR for the entire circuit, trying to calculate the resistance directly using this method. Okay, so for the entire circuit the voltage is 2 when it passes through these 3 resistances, because in the earlier part we calculated the resistance of the diode as 50 ohms. The other resistance 60 ohm is already given, so you can put an equation like 60 plus 50 plus resistance of X, what we are trying to calculate, is equal to the EMF of the battery divided by 15 milliamps. Then the question goes on to ask you to find the ratio of the power dissipated in resistor Y and the total power produced by the cell. So there are many equations to calculate the power. One is P is equal to VI, P is equal to I squared R, P is equal to V squared by R. Now for the battery we don't know what is the resistance of the battery, so that means we can only use P is equal to VI to find the power dissipated by the battery. Then you have to compare that total power produced by the battery, the cell, with the power dissipated in resistor Y. For the resistor Y we know everything. We know the voltage, we know the current, we know the resistance, so you can use anything. I would prefer using resistance and current, that is P is equal to I squared R, since it is V who calculated the voltage, but basically everything is same. So if you apply the equation, so you can see here there are 3 equations possible. P is equal to VI. Now this, don't be worried, P is equal to EI is for battery. The EM voltage, sometimes we refer it as the EMF E, so instead of V they use the symbol E as well, but otherwise it's basically voltage of the battery. P is equal to I squared R or P is equal to V squared by R, all are possible. So here they are using for the battery P is equal to VI, so basically this is your I and this is your V, 2 volts, 15 milliamps, and this is your I squared, and here's your R value, and you calculate 0.45, and you can similarly use the other equations as well. But you can see for all the equations the battery one is the same one, because for battery you don't know the resistance, so the only option that you are left with is P is equal to VI. But for the remaining you can use any of the 3. For Y you can use any of the 3. Okay, so that brings it to the end of that question.